Find the equivalent resistance across the two ends of the following circuit. So here the two ends are being given to you as A. This is A. From here you have a resistance here, capital R, another resistance, capital R, another resistance, capital R. Three resistances are there between A and B. Okay. From here, this point, you see, a wire goes and it connects here after two resistances here, like this way. And one wire goes from here, it connects like this way. This is R, this is also R, this is also R. You are asked to calculate, find the equivalent resistance across the two ends A and B. What resistance will you get across A and B? Okay? Yes. What equivalent resistance you will get across A and B? Yes, do it. Can you do? Here you see this combination is, here you see this question, in this question, this combination you start from A, this point A, right? Equivalent resistance of the circuit can be drawn in this manner. So first you start from A, then you see there's a junction right over here. You take this point as C, this junction as C, this junction as D, this junction as E, and this junction as F, right? You start from A, you go to C, and then you move to E, right? So here you see you start from C, then you go further, there's one resistance R, and then you reach this point D, because this is connected with B. The current here you see this goes here, and then from C to D, and D is directly connected to B. That means this is the current will flow in this direction between A and B. Got it? Next you see from this point, from C you again you see this current goes here E. So C here, from C this goes to E, and at E there's a resistance and then it reaches B. So it goes here and it finally reaches B. So this way it goes, and finally it reaches here at F. So C it moves and then it goes to E, E, and from E it goes to F. So this point is now F, right? This point is F. Okay. Now again you see, you go further and now you reach this point. Here you see this goes here like this way, and this goes here like this way, In between D and E, there are again a resistance. There's again a resistance between D and E. So you see, between D and E, there's another resistance. So here you see D and E. So this third resistance, you will draw it like this way. So there are three resistances, and all these three of them are parallel. This R, this R. See, start from here, goes to resistance, reaches B. Start from here, goes to B, and then here you go further. Okay, and this point here, there's D. Between D and E, there's another resistance, right? So D and E, there's another resistance. So D is there, E is there. There's another resistance R. So in this case, the combination of the resistance between A and B will be 1 upon R. Okay, equivalent resistance Re, you can write equivalent resistance is equal to 1 upon R plus 1 upon R plus 1 upon R, that is equal to 3 by R. So R equivalent resistance here will be R by 3. This is the proper circuit diagram of this, starting from A going to B, first resistance, then second resistance, and then third resistance, and finally you get this. Okay. Next question you see, assume that P and Q are at same potential. Assume that P and Q are at same potential. Assume that P and Q are at same potential. Find the equivalent resistance between A and B. Assume that A and B are at same potential. Find the equivalent resistance between A and B. Here you see in this question, you have to find out the equivalent resistance between A and B. Okay. So here, this is here. A's point is this. B is this. And from A you start, goes here. There's a resistance R, and this goes here further to point L, and there are two different resistances. This L, one resistance like this way, another resistance like this way, another here resistance like this way, another resistance like this way, and this point is given as P. This point is given as Q, and this point is given as M, and then it is connected to B like this way. This is it's connected here. So this is R, this is R. All our resistances are capital R. And the question is, you have to find out the effective resistance between A and B. Okay. So here you see, given that P and Q are at the same potential. P and Q are at the same potential. There's one more resistance which is starting from here, going to Q. So this is also R. So if P and Q are at same potential, so no current will flow from P and Q. Right on. If P and Q are at same potential, if P and Q are at same potential, if P and Q are at same potential, then no current will flow from P and Q. If P and Q are at same potential, then no current will flow from P and Q. Then no current will flow from P and Q. Okay. So from P and Q, there no current will be flowing. Therefore, therefore, the resistance between P and Q is ineffective. Therefore, the resistance between P and Q is ineffective. Hence the circuit can be redrawn as hence the circuit can be redrawn as you see you can redraw the circuit like this way. These are these are this also are this also are. Here you can take 2 points P and Q. So no current is flowing between P and Q, so no need to draw any resistance there. Right? So here this point is L and this point is M, right? So this is A, this is C, and this is D. Okay? This point junction, this is A, this is B, and this is B, right? This point is C and this point is D. Now you see the effective resistance you have to find out between A and B. So here this through this junction resistance through LM will be 1 upon R1, 1 upon RM, RLM. You can say we are going to calculate the resistance through this LM. So 1 upon RLM is equal to 1 upon R plus 1 upon R. That is equal to 2 by R. So RLM is equal to R by 2. Similarly, resistance across this and this point, you can say this downwards right, will also be, है so here you see this is R and this is R, so that will give you 2R. Okay, wait, this is also 2R, right? So that is going to give you these are between L and M. There's resistance will be given by resistance between L and M will be R plus R because they are in series combination, right? That is equal to 2R. And through below here you see this is also R plus R 2R. So total combination of resistance 1 upon RLM is equal to 1 upon 2R plus 1 upon 2R, that is equal to 2 upon 2R. 2 cancelled out, that is equal to 1 by R. So resistance RLM is equal to R. This point is clear. Now if this is R now, you have to calculate the remaining part, the resistance also. So here you see this combination was going showing this total above one is R. So the effective resistance between A and B will be given by 1 upon RAB will be equal to 1 upon R. They are in parallel now, plus 1 upon R. That is equal to 2 by R. So resistance between A and B is equal to R by 2. Okay? R by 2 ohms. Hurry up, do it fast. You see, these are the 2 points being given to you. Next question, A is this, B is this, and there's one resistance here. one resistance here, one resistance here, and one resistance here. Right. Then you have one resistance here, one resistance here, one resistance here, one resistance here. All these values are 2 ohms, 2 ohms, 2 ohms, 2 ohms, 2 ohms, 2 ohms, and 2 ohms. All are 2 ohms resistance. You have to calculate the effective resistance of the circuit, right? So here you see, in order to calculate the effective resistance of the circuit, what you will do here, very simple question it is. Here you see, this is 2 and this is 2, so they're parallel combination. So that will be 1 upon 2 plus 1 upon 2, that will give you what? 1 ohm. So this will give you 1 ohm. Similarly, this is also 1 ohm, this is also 1 ohm, this is also 1 ohm, right? So as a result, you get A point here, and there's a junction here. This will give you 1 ohm, this will give you 1 ohm. They are in series combination. This is 1 ohm, and this is also 1 ohm. This is 1 ohm, this is also 1 ohm. This B 1 plus 1 give you, that is going to give you 2, and this is also 2 ohms. So resistance between RAB is equal to 1 upon 2 plus 1 upon 2, that will give you 1. So RAB is equal to 1 ohm. Clear? Okay.